The graph of f of x is shown below, and we have to find these values. Let's try with f of 2. F of 2 is the value of the function at location 2. And actually at 2, if you think about this vertical line, it meets the graph in two different parts, right? There's this one and another one here. Now, because this one has a solid circle, whereas this one has an open circle, we follow that the value at 2 is really value at 2 is really 1. Okay, so a f of 2 would be 1. Now, what about the limit of the function as x approaches to 2 plus? So, if you're approaching 2 from the right, what's happening to the value? Well, just imagine that you are walking on this terrain, and this is a downhill, right? And you're approaching the location 2, and you're trying to be aware of your altitude. We know that altitude is the y-coordinate. Y-coordinate is the value of the function. So, as you pay attention to the altitude, that means you will figure out where the limit will be. As you get closer and closer to 2, the value of your altitude will be closer to negative 2, right? It's going to get closer and closer to negative 2. So in this case, the limit is x going to 2 plus of f of x equals to negative 2. Now notice that this is not the same thing as the value at 2. The value at 2 is 1, whereas the limit as you get closer and closer to 2 is negative 2. There's a big difference here, okay? Now part C is asking limit x goes to 2 of f of x. Well, this time the right limit is negative 2, however the left limit is 1, because if you are approaching 2 from the left and you're approaching, then what's happening to your altitude? Your altitude gets closer and closer to 1, so we know that limit of x going to 2 minus f of x is 1, whereas x going to 2 plus gives you negative 2. Since these are not equal, that means the left limit and the right limit do not equal to each other. That means the limit does not exist. Whenever you have a jump discontinuity, where there's a jump, then the left limit and the right limit won't agree, and therefore the limit will not exist. Okay, let's do just one more. D f of negative 1. Well, we go to location negative 1 and we look at the value. Well, the vertical line seems to pass through this open circle here, but the open circle, it means that there is no value there. So in other words, if you drew a vertical line on negative 1, that vertical line is not going to pass through, not going to overlap with the function, because this is empty. So in that case, what we say is that the value does not exist, but a more appropriate way to say it is the function f is not defined at negative 1. So we say undefined. Okay, and that's a better way to say it. Okay, let's move on to other questions. What about limit as x goes to negative 1 from the left? So here's negative 1, and you're trying to approach from the left. So again, you picture yourself walking towards negative 1 from the left, and as you walk on this terrain, you're paying attention to your height, your altitude, and your altitude is getting closer and closer to negative 1, right? So this part E, limit x going to negative 1 from the left of f of x would be negative 1. Okay, F, limit x going to 1 of f of 2x minus 3 is what? Well, for this one, one way to do it would be just to think that if x gets closer and closer to 1, 2x minus 3 gets closer and closer to negative 1, because 2 times 1 minus 3 is negative 1, right? So you're really asking, what's the limit as x goes to negative 1 of f? Now, if that didn't make sense, here's another way to think about it. You can substitute, say t is 2x minus 3. Just rewrite t as 2x minus 3. Then this limit will just simply be f of t, much easier to handle, right? The problem is, instead of x going to 1, what do you write? You have to say t goes to somewhere, right? But since when x is 1, t is what? 2 times 1 minus 3, so that's negative 1. 2 minus 3 is negative 1. So as x goes to 1, t goes close to negative 1. So you're looking for this limit. And for this limit, you see that you need to approach negative 1 from both sides. So if you approach negative 1 from both sides, whether you're walking from the left or the right, you see that they both arrive at this open circle there, and that they get close to negative 1. So this will be negative 1. Okay, so the answer to this will be negative 1. And this substitution helps us to understand it easily. Okay, what about f of 1? F of 1 is right here. If you get this 1, draw a vertical line, where does it meet the graph? Right here at negative 1. So f of 1 is also negative 1. Okay, now h, limit x goes to 0 of f of x. Well, you're trying to approach 0, and if you approach the location 0, either from left and right, in both directions you approach to this point, and that has the altitude 0, right? So this will be 0. I, what's f of 2, f of 2? Well, you first have to know what f of 2 is. We already answered that. F of 2 is 1, right? So we have f of 2 is 1, so I can replace f of 2 by 1. And what is f of 1? F of 1 is negative 1. Okay? And then j, find x values where the function is not continuous. Well, whenever you have an undefined point, or whenever you have a jump, or whenever you have a vertical asymptote, those are the points where the function is not continuous, right? So we see right away that in j, oh, why did I erase this? In j, you have r pod here. This thing's called r pod because there's like 2 whiskers coming out of a circle, right? So that's an r pod, removable point of discontinuity. So you have x equals to negative 1 is a removable discontinuity. And x equals to 2. At 2, the left limit and the right limit do not agree, so that's a jump discontinuity. Now k, where are the points where the function is not differentiable? Well, a function is not differentiable if it has discontinuity or if it has a sharp turn right here. Okay. So anytime it's not continuous, x equals to negative 1, x equals to 2, will be not differentiable, because not continuous. Okay. But also x equal to 1 is not differentiable because it has a sharp turn. Question 15. You have the value of the function given, and you have to find out these derivatives. F of g of x, and you have to, d dx just means differentiate, right? So you differentiate, and you plug in x equals to 2. And because this is a function g of x nested inside f, which is the outside function, you differentiate the outside, leave the inside unchanged, but you make a copy of the inside function outside, you bring the inside out, and then you do the derivative, okay? And then you plug in x equals to 2, which means f prime of g of 2 times g prime of 2. Now what is g of 2? That's 2, that's what it says. G of 2 is 2, so f prime of 2. G prime of 2 is negative 1, so it's negative 1. And f prime of 2 is negative 2, so it's negative 2 times negative 1, which is positive 2. How about b? This time you have f of x cubed prime, and you're plugging in x equals to 2. And again, fx is now inside function. The outside function is x cubed, right? You just think about f of x as big X, then you have x cubed. The derivative is 3x squared. But it's not x, it's f of x squared. And then you multiply by the derivative. And then you have to plug in x equals to 2. So that's 3 times f of 2 squared f prime of 2, which is 3 times f of 2 is 3 squared. F prime of 2 is negative 2. So that's 27 times negative 2, that's negative 54. Sketch the graph of the derivative of the following function. The easiest way to draw the graph of the given function is to just figure out where the graph has a horizontal asymptote. So let's see. Here, if you think about the tangent line, it's horizontal. Right? Here also, and here also. These are points where the tangent line is horizontal, and because derivative is the slope of the tangent line, when you have a horizontal tangent line, the slope is 0 and the derivative will be 0. Okay? So at negative 2, at 0, and at 3, those three are the places where the derivative would be equal to 0. So here's negative 2, 0, and positive 3. Those are the places where the derivative will be 0. So I'm going to put 0, 0. It has to pass through negative 2, 0, 0, 0, 3, 0. The graph of the derivative must pass through these 3 points. That's the important thing. Now, once you've figured out where the derivative is equal to 0, the next thing you want to do is you want to try to see whether the derivative is positive or negative by looking at whether the function is increasing or decreasing. Now, when you talk about a function increasing or decreasing, you always have to read from left to right. Okay? Read left to right for increasing and decreasing. Okay? So you read left to right, and therefore this curve right here, reading left to right, is going up, right? So it is increasing. If a function is increasing, that means the derivative is positive, right? Here it's decreasing, so the derivative must be negative. If the value of a function is negative, that means the graph will be below the x-axis, right? So just to make sure that we remember that, I'm going to put the minus sign below the x-axis. Okay, so I'm going to put the positive above the x-axis and negative sign below the x-axis. And then between 0 to 3, again the function is increasing, so it must be positive. And after 3, the function is decreasing, so it must be negative. It's plus, minus, so it's plus, minus, plus, minus. So what does that mean? Well, it means that the graph must be up here and below the x-axis, above the x-axis, and then below the x-axis. So that should be the graph of the derivative. Now you can make this much better by estimating the slope at these points, but most likely when you're taking the exam, this will be good enough. Okay? This shows you that you understand the meaning of the derivative. The meaning of the derivative is the slope of the tangent line, And whenever the function is increasing, the slope of the tangent line must be positive above the x-axis. Whenever it's decreasing, the slope of the tangent line should be negative, or the graph should be below the x-axis. That's how you do it. Find all values of x where the graph of fx has a horizontal tangent line. So we think about horizontal tangent line. Line that is horizontal means slope equal to 0. And because slope is the derivative, we're looking for f prime of x equal to 0. And that's it. You just find the derivative and set it equal to 0. That's what this question is about. So we differentiate. And set this equal to 0. Now, if you multiply 3 to negative 5, and you get negative 15, and you try to factor this by finding two numbers that multiply to negative 15 and add to negative 12, after some struggle, you'll find that there is no such a value. So, unfortunately, this cannot be factored simply, and therefore the only way to solve this would be to use the quadratic formula. So I hope you remember the quadratic formula. It's x equals to negative b plus minus square root b squared minus 4ac all over 2a. Okay. It's actually a song. You can actually sing that. So try to look up quadratic formula and see if you can remember it. Okay. All right. So you have now b is negative 12 plus minus square root of negative 12 squared minus 4 times 3 times negative 5 over 2 times 3. And that's 12 plus minus square root 144. Let's see, 4 times 5 is 20, 20 times 3 is 60, minus minus is plus, so it's plus 60, over 6, and 12 plus minus square root, that will be 204. Right? Now you can further simplify this by seeing that 204 is divisible by 4, so you can bring the 4 out, and the result is 4 comes out as a 2. 4 is 2 squared, so 4 comes out as a 2 square root, and 4 times 5 is 20, so it's 5. 4 times 1 is 4, so 51 over 6, and then top and bottom can be reduced by 2, so you get 6 plus minus square root of 51 over 3. Okay, so 6 plus minus square root of 51 over 3. Okay, the graph of two functions are given, and this time you have to find p prime, q prime, h prime. So p of x is given as f of x times g of x, and then you're being asked about p prime of 2, and what you need to do is you first have to differentiate, right? So we're going to differentiate this, and because it's a product, we're going to use the product rule. Differentiate the first, keep the second, plus keep the first, differentiate the second. And then you plug in 2, which is f prime of 2, g of 2, plus f of 2 times g prime of 2. So this should feel like some of the previous questions where f and g were not given, but the value of the function at these points are given. The difference is now you're given the graph, not the value. So from here we have to figure out the value. So at 2, let's think about the values of f and g. First, f of 2 is 1, because at 2 the height is 1. Right? This is 2 comma 1. So we know that f of 2 is 1. Now what about f prime of 2? F prime of 2 is the slope at 2, so it's this slope, right? How do you get the slope? You do it by rise over 1. So you have to pick 2 points and find the slope between the two, rise over 1 between the two. So I'm going to choose this one and this one. And to go from this to that, you need to go down by 2 and run by 1. So rise is -2, run is 1, so -2 is the slope. Okay, let's do the same thing for g. For g, it passes through 2, -2. So g of 2 is -2. And g prime of 2, again, you have to pick 2 points. Let's pick this point and this point. To go from here to there, you rise by 1 and you run by 2. So rise is 1, run is 2. Therefore, we have these values, and that's good enough for us to figure out p prime of 2, because now I know that f prime of 2 is -2, g of 2 is -2, f of 2 is 1, g prime of 2 is 1/2, which is +4 plus 1/2, which is 9 over 2. We try to use improper fractions over mixed fractions, so don't write 4 and 1/2 in calculus. Same deal with pre-calculus. In pre-calculus and calculus, you use mixed fractions, improper fractions, not mixed fractions. Okay, so you want to write 9 over 2. Let's do the same thing for q of x. Q prime of x, because q of x is the quotient, so if you differentiate this, you get the quotient rule. Hopefully you remember the quotient rule. Okay, divided by gx squared. Okay, and then you have g prime of 2 as f prime of 2 g of 2 minus f of 2 g prime of 2 over g of 2 squared. So what's that? F prime of 2 is, well, we have it here, 1, okay, so it's 1 times, sorry, f prime of 2 is -2, right? It's essentially this one, except you see the difference between the product rule and the quotient rule is quotient rule has the denominator squared, and then the plus becomes minus, right? So we can just look at this and change that to a minus. So you get 4 minus 1/2. And g of 2 is -2, so you put -2 squared. 4 minus 2 would be 7 over 2, because 4 is 8 over 2. 8 over 2 minus 1/2 is 7 over 2. And then you divide that by 2 squared, which is 4. So in this case, the answer will be 7 over 8. So those two will be the answer. So this one will be the answer. Okay, now let's try h of x, g composed with f, and h prime 0 and h prime of 2. Now, this circle means composition of two functions. That's really g of f of x. Now, h prime of x, therefore, would be g prime of f of x times f prime of x by the chain rule. The chain rule says differentiate the outside function, make a copy of the inside function, and differentiate that. So what we're trying to do is, what is h prime of 0, which is g prime of f of 0 times f prime of 0, and h prime of 2, which is g prime of f of 2 of f prime of 2. Okay, let's do one by one. H prime of 0 is g prime of f of 0. What is f of 0? At 0, this point 2, so 0 comma 2 is a point that f passes through, so f of 0 would be 2. And also for f prime, we also need f prime of 0, right? So f prime of 0 is the slope here. The slope is rise over 1, so we just pick these 2 points. These are straight lines, so I have the slope. So rise by 1, run by 1, so it's 1 over 1, which is just 1, okay? So this f prime of 1, f prime of 0 would be 1, f of 0 would be 2. So g prime of 2 times f prime of 0, which is 1. Okay. And we just did g prime of 2. What was it? G prime of 2 is 1/2, right? So this is 1/2 times 1, giving you 1/2 as the answer. H prime of 2 is g prime of f2 and f prime of 2. Let's also look at that. We just did it. It's f2 is 1, f prime of 2 is negative 2. So it's g prime of 1 and times negative 2. Okay. F of 2 is 1, f prime of 2 is negative 2. And what is g prime of 1? We go back to g and look at g prime. It's right here. And this slope is same as the slope at 2, right? So g prime of 2 is same thing as g prime of 1 because g prime of 1 and g prime of 2 are on the same line. So it has the same slope. That means this will be 1/2 times negative 2, which will give you negative 1. Find the derivative and then find the tangent line. Okay, this type of question uses the derivative to find the slope of the tangent line, and it asks you to find the equation for the tangent line. Okay, let's try to differentiate f. So we differentiate this. Because it's a quotient, we have to use the quotient rule. And then denominator squared. And then x plus 2 differentiates to 1 minus x plus 2. Square root of x differentiates to 1 over 2 radical x. Okay, that's something you should memorize. It appears often. You could try to get that by writing x square root as 1/2 power. And use the power rule, 1/2 comes down and x to the negative 1/2. But after that, you have to do so many other things. It's better to just memorize this. Square root and square cancel, so you just have x. Alright, so what is f prime of... So that's the answer to part A. Okay. Now, if you really want to simplify this, I guess one way to simplify it is by multiplying by square root of x top and bottom. Then I chose to multiply square root of x because that's part of the denominator. Oh, actually, you know what? I should multiply 2 radical x so I can get rid of this completely. Okay. So what do you get if you multiply 2 radical x times square root of x? That gives you 2x, right? And then x plus 2 times 1 over 2 radical x. This 2 radical x will cancel with the top 2 radical x. So you're just going to get x plus 2. In the bottom, you're going to get 2 times x times square root of x. Okay. And 2x minus x is just x minus 2 over 2x square root of x. Okay. And since I'm going to use this to find the answer to the next one, it's much better to simplify it. Okay. So that's our answer to part A. To get the part B, I am going to find the slope at 4,3. Now, because I've said derivative is the slope, derivative is the slope so many times, people misunderstand that this is the slope. That's not right. Only when you evaluate this at the given point, you get the slope at that point. So since x is 4 here, this means x is 4 and y is 3, right? So because of that, you set x equals to 4, and the slope is f prime evaluated at x equals to 4, which gives you 4 minus 2 over 2 times 4 times square root of 4. So that's 2 over 2 times 4 times square root of 4 is 2, right? 2 cancels and you get 1/8. So that's the slope. Once you have the slope, then whenever you try to find the equation of the tangent line, you have to use the point slope form. So this is the point slope form. And you have y minus y0 is 3, m is 1/8, x minus, and x0 is 4. Okay, so x is 4, y is 3, so this is really your x naught comma y naught. You plugging it into the quotient, point slope form gives you this equation. Now let's simplify this to get the slope intercept form. It will be 1/8 multiplied, it's going to be 1/8 x, and 1/8 times -4 is -1/2, right? And because you have to add 3 both sides, you're going to be adding 3, so that gives you y equals to 1/8 of x. 3 is 6/2, 6/2 minus 1/2 is 5/2. So that's the answer. Find the derivative. X minus 2 over x minus 1 prime. You differentiate separately. The first one is easy, it's just 1. The second one, you'll need to use the quotient rule because it's a quotient. And 2 prime, 2 is a constant, so that gives you 0. 0 times anything is 0. So it's 1 minus -2. And x differentiates to 1. X minus 1 squared. So that just gives you -2, but there's a minus in front, so you have 1 plus 2 over x minus 1 squared. Okay? How about this one? This is another quotient rule question. And sometimes you don't always get a function of x. A lot of times when you deal with functions in physics or other business or other situations, your variables may be named as a or s or y or z or whatever. Okay, so you have to think of s as if it's x, and if it really confuses you, another thing that you can do is just rewrite this as x over square root of x plus 1, and then differentiate this, and after you get the answer, try to rewrite all the x's as s. So that will be another way to do it if it really confuses you. But you should challenge your mind to differentiate as this. Okay. All right. So you have to use the quotient rule because it's a quotient. And then this denominator squared. S prime is 1. Square root of s is 1 over 2 radical s. I ask people to memorize this. Very handy. And then 1 differentiates to 0. And then you have square root of s plus 1 squared. Okay. Now in the practice sheet I said you don't have to simplify, so you can just leave it like this. As long as you've handled all the derivatives, I don't see any primes here, right? So that's done. That's the answer. Okay. Sometimes it's better to simplify algebraically before you do the derivative, because I mean, if you try to do the derivative of this, it's crazy because the top has to be differentiated separately with, I mean, you have to use the quotient rule, but then when you differentiate the top, you have to use the quotient rule again. This is very crazy. So instead of trying to approach it like this, let's first try to find out what this is equal to by simplifying the complex fractions. Now, whenever you have a fraction inside a fraction, I have to tell you, there are many strategies, but the best strategy is to just look at all the denominators and just multiply it top and bottom. I've yet to find anything that's better than this. Okay, so I see x minus 1 as the denominators, just multiply x minus 1. So x minus 1 times 1 gives you x minus 1. 1 over x minus 1 times x minus 1, they cancel and gives you minus 1. 1 times x minus 1, that's x minus 1. 1 over x minus 1 times x minus 1, that's plus 1. So you end up with x minus 2 over x. Now you can further simplify this by making it as x over x minus 2 over x, right? And x over x is 1, so it's 1 minus 2 over x. Now on top of this, it's good if you remember that 1 over x prime is equal to negative 1 over x squared. You can get this result by thinking of 1 over x as x to negative 1 and you apply the power rule. But it's better if you just memorize this, okay? So therefore, you have 1 minus 1 over x minus 1 over 1 plus 1 over x minus 1 prime. The same thing as 1 minus 2 over x prime, okay? Because these two are equal as algebraic functions, right? These two are the same thing. So differentiating this gives you 1 differentiates to 0, and negative 2 times 1 over x differentiates to negative 1 over x squared. So the final answer is 2 over x squared. Okay? And that's much better. If you try to differentiate this as it is, it'll be a nightmare. It might take like an entire page. And the final result will be really hard to use too. Okay. And here's another idea. Here you could use the product rule because it's a product of two functions, right? It's this one times that one. However, you have to write these as x to the 1/3 power anyways when you want to differentiate, so you have to do some form of simplification before you multiply, before you differentiate. But when you see that this 1/3 and 2/3 adds up to 1, you see that it's easier if you can simplify further by just multiplying. So x to the 1/3 times 1 is x to the 1/3, and if you have the same base, the exponents add up, right? So 1/3 plus 2/3 is 1, so you just have x. And x to the 1/3 plus x, that is much simpler than this, and it's a lot easier to differentiate, right? So the tip or the lesson learned here is that if you can simplify what you're given, then please do that first and then differentiate, because simpler functions are easier to differentiate, of course, right? Okay, so that's the answer. Okay, this time ax cubed plus bx. How do you differentiate that? Well, that's 3 comes down, ax squared, and differentiating x gives you b. Now, you might be a little confused because a and b are some constants. If that really confuses you, then try to work with some constants that you can easily distinguish from the other one. So just think about 7x cubed plus 2x, something like this. How do you differentiate? It's simply differentiate this, differentiate that, right? So 3 comes down, and x differentiates to 1. It's exactly the same concept, right? So 3 is here, a is like the 7, and b is like the 2. So it's the same thing. Okay, what about this? Well, you can't do much. It's quotient, so you have to use the quotient rule. Now there is a way to make it maybe slightly more simpler by turning this into a product rule, because 1 over square root of x is x to the negative 1/2 power, right? So you can bring these over up there and turn that into a product rule. So that might be easier. Let me try to do both, okay? And you can choose whichever seems to be easier. Now the only reason this way of doing it works is because you don't have any other terms. It's just 2 radical x. If I had like plus 1 in the denominator, then you're stuck with the quotient rule. So, and then if you're stuck with the quotient, then you have to use the quotient rule. So it's not always possible to get out of having to use the quotient rule. You have to memorize the quotient rule. Okay, so let's apply the quotient rule. Differentiate the first times the second, but then minus, and you do first times, now differentiate the second, over the denominator squared. E to the x differentiates to e to the x, and square root of x, that differentiates to 1 over 2 radical x. By now you should probably have memorized it. and 2 squared is 4, square root of x squared is x. So that's it. Okay, so it's not too bad. Now if you want to use the product rule, then you can do it like this. This is the same thing as 1/2 times e to the x times x to the negative 1/2, because of what I just said, right? And because 1/2 is just a constant multiple, you can just differentiate e to the x to the negative 1/2. And because now you have a product of two functions, you can use the product rule, which is differentiate the first, don't do anything to the second, but now in the second stage, differentiate the second. And that's equal to 1/2 e to the x differentiates to e to the x, and then plus this is the power rule, so it's 1/2 negative 1/2 comes down, subtract 1 off of negative 1/2, that's negative 3/2. Okay, now the results look very different, but if you simplify both of them, then they're going to simplify to the same thing. Okay, now what about this one? Well, that one, these are two terms, so you have to differentiate this and differentiate this separately. And they're both products, right? Now you can get out of having to use product rule here because this is x to the first power, x to the 1/2 power, so it's at overall x to the 3/2. You can do that too. Try that. It's going to do the same. It's going to give you the same result, okay? But since I don't have to simplify the final answer, just applying the product rule will do fine, okay? So product rule, differentiate the first, keep the second, plus keep the first, differentiate the second, minus differentiate the first, keep the second, plus keep the first, and then differentiate the second. E to the x differentiates to e to the x. Square root of x differentiates to 1/2 radical x. 2x differentiates to 2. And then square root of x differentiates to 1/2 radical x. And then that's it. We don't have to simplify, so we're going to stop here. And make sure your final answer doesn't have any more primes. To solve the derivative means you have to at least take care of all the derivatives. X squared plus 2 to the 5th power. This time it's the chain rule because this x squared plus 2 is inside the 5th power function. Okay, so we can do something like u equals to x squared plus 2, so that the above looks like u to the 5th power, and when you differentiate this by du, that's 5 times u to the 4th power. And therefore, if you differentiate the above as x squared plus 2 to the 5th power, that's like differentiating this by u times du dx. That's the chain rule, right? And because u to the 5th power gives you 5u to the 4th, it's 5u to the 4th, where u is x squared plus 2. And then du dx is, well, what is du dx? If you differentiate u by x, you get x squared differentiates to 2x, 2 differentiates to 0, so it's just 2x. So that's the answer. Okay. So that's how you would solve it using the Leibniz method. It's often more complicated. So let's try the second method. You just think about this as big X, and derivative of x to the 5th power is 5x to the 4th, right? So if you differentiate this, is 5x to the 4th, except that it's not the x here, it's really the x squared plus 2 that's there, okay? But every time you do that, you have to make a copy of the inside function, and you have to differentiate that. Okay, that's the chain rule. Chain rule says differentiate the outside function, treating the inside function as a big X. And then, once you're done with differentiating the outside function, make a copy of the inside function outside, and you differentiate that, okay? And that gives you x squared differentiates to 2x. Okay, 2 prime is 0, okay? All right. Now this one here is negative x squared plus 2x plus 1 the 1/2 power prime. So again, it looks similar. This is like u, right? It's the inside function. So you treat the inside function as x to the 1/2 power, which differentiates to 1/2, and subtract 1 off of 1/2, that's negative 1/2, times you make a copy of the inside function, differentiate it. So that's going to be x squared differentiates to 2x, 2x differentiates to 2, 1 differentiates to 0. That's it. Now this is an interesting question. See, they look the same, but it's different, right? Here, log of x is the inside function, and here x squared is the inside function. So when you use the chain rule, you have to be careful. So we differentiate this. Of course, these two are two different terms, so we can just differentiate term by term. So we have two terms that are differentiated separately. And then here, ln of x squared has ln of x as the inside function, and something squared is the outside function, right? So x squared, big X squared is the outside function, which differentiates to 2 times big X, but the big X is this inside function, which is ln of x. Now you make a copy of the inside function and you differentiate. Okay. What's the derivative of ln of x? ln of x prime is 1 over x, don't forget. So this time x squared is the inside function, so you treat that like a big X. So you differentiate ln of big X, which is 1 over x, so it's 1 over big X, but the big X is x squared. And times you make a copy of the inside function and you differentiate. And as I said, ln of x prime is 1 over x, so it's 2 times ln of x times 1 over x. Whereas over here, x squared differentiates to 2x. Okay, and you can simplify further by canceling this x with one of the x's here, but since we don't have to simplify, that's it. Okay. Here's a simple problem. 4 plus x squared is the inside function, right? So treat that as a big X. ln of big X differentiates to 1 over big X, but the big X is 4 plus x squared. Make a copy of the inside function, differentiate. 1 over 4 plus x squared times 4 differentiates to 0, x squared differentiates to 2x. So the answer is 2x over 4 plus x squared. Okay, let's do something easy for a change. Or is it easy? Well, to do this, x squared differentiates to 2x, that's easy. X cubed differentiates to 3x squared, that's easy. 5 to the x power, what's that? Well, a to the x power prime is a to the x times ln of a. So if you differentiate this, we have to differentiate term by term. And any constant multiple can be brought outside, okay? 5 to the x. This 5 is not a constant multiple, it's part of the function, so you have no choice but to do this. And then minus 5 to the 7th prime. X squared differentiates to 2x. X cubed differentiates to 3x squared. 5 to the x differentiates to a to the x ln a using this formula, right? So it's plus 5 to the x times ln of 5. Now this last one here, 5 to the 7th power, well, it looks like a function, but that's a number. That's a huge number. I don't know what it is. You just multiply 5 to itself 7 times, but that's a number. Any constant, if you differentiate, you get 0. So don't be fooled by how it looks. It's not a function of x because it doesn't have any x. If it doesn't have any x, that means it's a constant, and constant differentiates to 0. So that's it. Now let's try this one. If you differentiate this, 2x cubed e to the 5x plus 2 prime. This is a product of 2x cubed and e to the 5x plus 2. So I can use the product rule to differentiate it. And 2x cubed differentiates to 2 times 3x squared e to the 5x plus 2. And when you differentiate this, you see that 5x plus 2 is the inside function. In other words, if you cover this 5x plus 2 by a big X, then it looks like e to the x, and I know the derivative of e to the x is e to the x, right? So the derivative of this will look like e to the x, where the big X is this inside function 5x plus 2. But then, because we've covered the inside function, that inside function has to, at some point, be differentiated. That's why I make a copy of it and put a prime outside. Okay. 2 times 3 is 6. And then 2x cubed e to the 5x plus 2. And then 5x differentiates to 5. 2 differentiates to 0. So that's all you get.